In this particular session, we are going to talk about unlocking mechanisms, mediation analysis in SmartPLS. So we are going to understand what is mediation analysis and how to conduct it. So in this particular session, I'll be covering understanding the mediation analysis, with the help of the steps. Before conducting mediation test, what are the things we have to complete? What are the prerequisites one has to have it? So in that case, we also need to cover what is measurement model, what is structural model, with the help of the data that we are going to discuss, testing mediation in a SmartPLS, and moving from explanation to prediction. So we are also going to discuss PLS predict as well as CVPAT. This is what we are going to cover as a part of this particular session. Now, once again, I would like to thank various scholars for their contribution. My special thanks goes to Chow Yan for his entire support in the process of working, learning step-by-step guide, PLS-SEM, data analysis using SmartPLS, one of the best source. So I would like to acknowledge Chow Yang for his entire contribution, which will help me to take this particular session and to reach many of you. Okay. Now, as we have mentioned that if you want to conduct whether it is mediation analysis, whether it is a moderation analysis, without understanding the construct, we have got it. Like, for example, if you are going to have around 4 construct, 5 construct, whatever may be the construct that you have it. If you want to look at the mediation or if you want to look at the moderation, we should complete measurement model. As a part of the measurement, we are going to talk about reliability test, validity test, within the validity, discriminant validity, convergent validity, then structural assessment model, then mediation. Then we'll talk about within the mediation, whether it is a direct effect, indirect effect, total effect. So there are different types of mediations we have. So we'll see one by one. Okay. Now, first try to understand the concept of what is mediation. Mediation occurs when a construct intervenes between 2 related constructs. Now, as you can see on this slide, we have 2 components. Okay. Now, let's take, for example, in the previous class, we have teacher qualities and we have school performance, as we already worked with the data. Now, teacher qualities have direct impact on the school performance. If there is a case, then this is called direct effect. As a teacher, if I'm going to directly influence the school performance, this is called direct effect. Now, in place of along with the teacher qualities, I also require the support of my students' performance, or I also require the support of my non-teaching, non-admin staff members also, right? So as a teacher directly, how much I'm going to influence the school performance? With the help of the other stakeholders, name it admin staff, name it teachers, name it research scholars, name it funding institutions, how we are directly influencing the school performance. If the independent variable is going to have direct influence on the dependent variable, that is called direct effect. But if I'm taking the help of the mediator for influencing, mediation occurs when a mediator intervenes between 2 related constructs. We have 2 constructs. We have mediator which is intervening to influence the outcome. It explains the process or mechanism and how and why. So here, if it is a direct effect, but if I'm going to influence with the help of the stakeholders, there is going to be indirect effect. Now we have 3 concepts: direct effect, that is from independent variable to dependent variable; indirect effect, that is coming from teacher qualities to admin staff to school performance. That's called indirect effect. Now, when I say total effect is nothing but direct effect plus indirect effect. This is called total effect. So we are going to discuss with the help of the data in coming slides, maybe after 20-15 minutes. Okay. A key insight: a significant total effect is not required test for mediation. Total effect is nothing but direct effect plus indirect effect. If I'm getting indirect effect, That makes the difference. What is the role of the mediator? As a mediator, if they're not influencing, then there's no role of the mediator here. So let's see it one by one. When it comes to the interpretation part, is indirect effect is significant? Like here we have the indirect effect is having any kind of significance. If yes, okay, we got some mediator is playing an important role. If indirect is not playing an important role, if this particular value is not having significance, then we say that no mediation. Now, is direct effect only significant? The outcome is indirect only mediation. Indirect only mediation. Now here, as we are going to calculate direct effect, indirect effect, we are going to look at whether value is negative or positive. So based on this, I'm going to explain this particular slide, maybe after a couple of minutes. When I say indirect only mediation, indirect effect is significant. Like as a mediator, they're playing an important role on the dependent variable, on the outcome variable. Okay, but there is no direct effect. This particular independent variable is not having influence on the dependent variable. So there is no significant, but mediator is playing an important role. Okay, now in that case, the independent variable influences the outcome slowly through the mediator. So this is known as full mediation. I'm just repeating again. As a independent variable, this particular variable is not able to influence the directly dependent variable. But independent variable is able to influence the outcome with the help of the mediator. So as independent variable is not playing any role, this is called full mediation. Okay, next one. Complementary mediation. Indirect effect is significant. Direct effect is significant. And at the end, it is known as both points in the same direction. Direct as independent variable is having influence on the dependent variable. Mediator is also having influence on the dependent variable. This is called partial mediation. As a mediator, we are playing partial role. In the previous case, it was playing full role because there was no direct effect. Okay. Next one, last one. Indirect effect is significant. Okay. Direct is significant, but we got some negative values. The path complete. The mediator acts as a suppressor or buffer, reducing the magnitude of the total relationship. So this particular point we can able to understand with the help of the data. So in order to understand this particular context, we have some sample data set with us. We are trying to understand the role of mediating effect of helping behavior on two important variables. One is teamwork, second one is work stress. If you look at the data set, I have given data. It consists of three variables, three constructs: helping behavior, teamwork, work stress. Now, I just want to understand what is the role of the mediator, that is helping behavior, relationship between teamwork and work stress. Right. Let me go to the next. So this is the data set they have shared. We have one variable, that is a teamwork, which is considered as independent variable. And we have another variable, that is work stress. This is a dependent variable. And I want to know whether teamwork is having any kind of influence on the work stress. I just want to understand the direct effect of teamwork on the work stress. That is one of my research hypothesis or objective. Second one, the direct effect of teamwork on the helping behavior. Before looking at the role of the mediator, I also need to see whether teamwork is having any kind of influence. I just want to understand the direct effect of teamwork on the helping behavior. Second one, I just also want to know direct effect of helping behavior on the work stress. Lastly, I just want to know that the mediating effect of helping behavior on the causal relationship between teamwork and work stress. Now here I have four objectives. You can call it as a hypothesis later on. You can frame it as a hypothesis. My first objective is whether teamwork is having any kind of direct effect. Teamwork on the stress, teamwork on the helping behavior on the work stress. These are the three. Direct. Teamwork to work stress is direct. Teamwork to helping behavior is a direct. Helping behavior to stress is the direct. In addition to that, the mediating effect of helping behavior on the causal relationship between teamwork and work stress. So I have total 4 objectives I have it. Okay. Now, as I mentioned it, if you want to assess the whether it's a mediation, whether it's a moderation, what you have to do, we have to conduct basic measurements. Like first one is we should know we have 3 construct we have. One is teamwork, stress, helping behavior. And in order to construct this particular latent variables, we have certain indicators. Like teamwork is having 5 indicators, helping behavior is having around 6 to 7 indicators, and stress also have a couple of indicators. Now, while the researcher designed this particular tool, they might have taken the help of the existing literature review. They have come up with this particular existing research tool. Now, before going for seeing the relationship, before going for looking for mediating analysis, we need to conduct the measurement model assessment, then structural model assessment, then comes to the finally mediation analysis. In case the constructs are not valid, if they're not having good reliability, validity, and we cannot able to come up with good conclusion, what kind of relationship they have it, how they're able to contribute. Further, we can also not able to understand the role of the mediator as well. So first what we are going to conduct, we are going to conduct measurement model. So we have a couple of parameters to assess it. Reliability construct, our value should be greater than 0.70. Convergent validity, it should be greater than 0.50. Discriminant validity, our value should be less than 0.85. Okay. And similarly, we also have collinearity test. Our value should be less than 5.0, or you can also consider 3.0. Okay. Then we'll see that how this particular constructs are, what is variance, how each dependent variable is able to influence other variables. Okay. Now, so please open your data set. We are going to measure construct reliability, construct validity, convergent validity, and discriminant validity. I'm not going a little bit step by step because we already done. It is more of repetition so that we can able to understand how to conduct once again measurement model as well as structural model, and then we'll go for mediation analysis. Please open your sample data set. Please open the sample data set that I have shared to all. Just click on new project. Title of the project is teamwork. Title of the project is teamwork. Just click on create. So we have the project. We already got the project. Those are attending for the first time, those who missed previous videos, I request you all watch my YouTube channel. How I will share it with you all. If you're new to the PLS-SEM, first of all, we have to create new workspace. Then only I have to create the new project. Okay. Now, as we created the new project, we are going to import the data file. In order to import the data file, just locate the file from wherever you have saved your file. Just click on the import data file. The moment I selected the file, I got the option and I can maximize it. You can see that there are 209 respondents. We have collected, this particular scholar collected data from 209 respondents. And we have teamwork, helping behavior, stress, thinking, motivation. I'll deal with thinking and motivation, intention later on as a part of the moderation in coming slide, tomorrow session. Teamwork, we have helping behavior, we have. Then we have stress. teamwork, helping behavior, stress. These are the variables that you're going to use as a part of this particular construct. Now, looking at the missing values, we don't have any missing values. Either you can consider as the metric data or you can consider as the ordinal data. If you want to change all the variables at a time, just go to the bulk change, select the variable that you want to choose, ordinal. Minimum value is 1, maximum value is 11. Just click on apply. Now you can see that all the variables for all the indicators, we have given scale as ordinal. Okay. Just click on import. Just click on the import. Now you can see that we got the descriptive statistics, which as a researcher, you have to present in your research report. Like as a part of this data, you can copy it in Excel or Word document, and you can take indicator, name of the indicator, mean values, and you can also take, if required, median value, but mean, kurtosis values, skewness values, and p-value, and see whether these values are they able to achieve you have normal distribution or not. If you have watched day 1 or day 2 session, that is as a part of the day 2, day 3 session, we discussed certain threshold values. Skewness and kurtosis value should be, if they are -1 to +1, we have achieved excellent normality distribution. If it is between -2 +2, acceptable. If it is between -3 and +3, there is some problem with your data. Now you look at the data set. If you look at the data, the indicator wise, we are able to achieve the normality distribution. Okay. Now just come to the raw data. This is what the responses we got it from the whenever we have collected data. This is the response that we got it. Okay. This is the raw data. Now just go back. As we already collected the data, we have imported it, and we are able to see that our data is distributed normally. Now just click on create model. Now we are going to create the model. In order to create the model, just give the name, model type as PLS-SEM, and what kind of model that you are going to create it. What kind of model that you are going to create it. Here again, I'm just giving, as we are going to check it, let me give measurement model. I'm just giving as a measurement model. Just click on save. So on the left side of the window, we have all the indicators. On the right side of the window, we have the panel, PLS-SEM model. So this is the way we are going to draw our graphical representation or our hypothetical model. Okay. Now, what we are going to do, this is not new. First time we are doing, we have done 2 days. So I have selected team 1, teamwork 1 to teamwork 5. Drag and drop it here. Just click enter. And I don't want to show ordinal label name, ordinal data. Okay. So on the right side, we have tools are available here. At the bottom of the window, you can able to see there is a special marker. Just click on the special marker. You can see that we are able to remove name of the variable like ordinal data, right? Then by using these particular tools, I can change however I want to change it. Okay. So right now I'm just keeping the left side. And you can organize your data. As we have only 3 variables, 3 constructs, we have it, 3 latent variables. One is teamwork. Second one, we have stress. In stress, we have 4 indicators. With the help of shift plus down arrow button, please select the name of the construct, that is stress. Drag and drop it on the right side of the window. Just click enter and arrange the constructs. Okay. Now, next one we have helping behavior. Right now, I'm just looking at it as a construct. Okay. So I'm just dragging and dropping here. Helping behavior we have. Let me put it down. Just you can organize your data. I believe some of you might be practicing it. If you have something new to this, how to arrange it. Okay. Now, I'm just going to connect it. In order to connect it, what I have to do? Just there is a on the right side, on the top of the window, in panel, we have connect. Just click on this particular connect and connect to the particular variables. Like we have direct, I want to see direct effect of teamwork on the stress, direct effect of teamwork on the helping behavior, direct effect of helping behavior on the stress. Okay. So we have designed it this way. Okay. Now you can arrange it however you want to make it out. After doing next, what is the next one you have to do it? As we are completely drawing the hypothetical model, we are going to analyze the measurement model for the constructs in terms of validity and reliability. So when you talk about the construct validity reliability, we are going to look at the relationship between indicators to the construct. And another important point, in the previous example that I have used, we have two types of construct: reflective construct, formative construct. Whereas in this particular model, we have three constructs, which are all three are reflective constructs. All three are reflective constructs. Means you can see that indicators are going from construct to the, or arrows are going from construct to the indicators. Okay. Now I just want to know whether this particular item, this particular indicator is able to measure the construct. What is the relationship between the construct and this particular indicator? So with the help of the factor loadings, we are going to measure whether this particular indicators are able to construct, are able to define this particular construct or not. What is the reliability and validity of this particular construct that we have? So first one, in order to check the construct validity reliability, and as we have only reflective constructs, this is the most important point. But I have seen many scholars, they use randomly only standard PLS algorithm. But whenever we have only reflective construct, we are going to use consistent algorithm, PLS algorithm, consistent PLS-SEM bootstrapping method, not standard algorithms. Whenever we have reflective construct, we are going to use consistent algorithms. Okay. Now, first and foremost thing, what we are going to do, we are going to do it consistent PLS bootstrapping method. Just click on it. And as you know that we have done several times, I'm not going to make any changes here. Just click on start calculation. Now here you can see that on the left side of the window, as we are conducting the measurement models, I just want to keep structural model as a blank. Structural model as a blank. As a part of the measurement model, I'm looking at the factor loadings and p-values. I'm looking at the factor loadings and p-values. If I have formative construct, I used to call them as, we have to call it as the outer weights. Now, as we have reflective construct, we call them as a factor loadings and p-values. Now look at here. And our p-value, which should be significant. We should have significant relationship between the construct and the indicator. Now I just want to check it out whether all the indicators have significance difference. Are they significant? Our p-value less than 0.05 for the helping behavior. So there is a significant relationship between helping behavior and the construct. Second point, I can also see that my factor loading value is greater than 0.7. Like here you can see that almost there is one construct, like one indicator, it is 0.673. 0.673. Now thing is that you have prepared this particular indicators, this particular construct with the help of the existing literature review. If you feel this particular indicator has to be there, I don't want to delete it. If you don't want to delete any of the indicators based on certain strong foundation, if you have it, in that case, you are free to delete any of the construct, any of the indicator that you have it. I'm repeating again. If your value is less than 0.7, if your value is less than 0.7 and less than 7.7 means, for example, if it is 5 or close to 6 or 6.2, 6.3, you can delete it directly, this particular indicator. But if your theory or particular existing literature suggests that no, you can't delete this particular indicator, this is one of the most important indicator as a part of the study. So in that case, you can keep it. However, if the value is less than 6, it is always better to remove it. If it is between 6.5, 7, so you can go a little bit liberal and you can think of keeping it. Okay. So right now, it is close to 7. So I'm not right now deleting it. Let's see how it is going to be there. Okay. Now, coming to the next construct. So we have all the significant results and all are greater than 7. Similarly, here also you can see that all are greater than 7 factor loadings and we got the significant results. So in that case, we are able to achieve that factor loadings. There is a good relationship between factor loadings and the construct, the indicators and the construct that we have it. Point number 1, that is clear. If any indicator is not valid, if having less than threshold value, we can remove that particular construct, that particular indicator directly. Okay. Now, next one. Just go to click on edit, calculate, consistent PLS-SEM algorithm. We are going to measure the construct reliability and validity. Just start calculation. Now just come here. As a part of the graphical output, left side of the window, we are looking at the measurement model, not the structural model. So I'm going to keep structural model as a blank. Okay. Now coming to the outer weights, measurement model. You can see here, we have what we have things we are going to look at here. Measurement model. We already completed the factor loadings. Now you want to see the Cronbach alpha, composite reliability. You want to see the AVA, construct validity, and discriminant validity that we are going to look at here. Right. So in that case, we are going to select outer loadings and R square will be construct will be blank. Okay. After doing this particular part, come to the quality criteria. After giving specific requirements, come to the quality criteria. Just you can scroll your cursor down. Scroll your cursor down. You can see we have option called construct reliability and validity. Under the quality criteria, we have construct reliability and validity. Now, the moment I just click construct validity and reliability, I got the overview. It is presenting what is Cronbach alpha value, composite reliability, and average variance extracted. We all discussed these particular concepts. So I'm not repeating what it is, but to put it simple, our Cronbach alpha value, that is internal consistency value, is greater than 0.70. Means there is an internal consistency is very good. All the items, Cronbach alpha considers all the items have equal consistency. Whereas composite reliability, it takes the values of the factor loadings and average variance, error variance, it will calculate it. So as compared with the Cronbach alpha value, composite reliability is considered more accurate. Okay. Now, when it comes to the convergent validity, that is called average variance extracted. So within the construct, like we have construct, within the construct, how indicators are able to measure. Like we have teamwork, we have helping behavior, we have stress. How this particular, within that construct, how this particular indicators are able to measure the concept. That is one thing. Let me do. So average variance extracted, we are trying to measure the entire construct after looking at each and every indicator, factor loading plus error of variance. We are going to calculate average variance extracted. If you require more details, please check it the detail session. I have given the formula. We have looked at step by step how to calculate the average variance extracted. Okay. So next one we have discriminant validity. Though I'm not going detail again, but as a part of discriminant validity, we have three important threshold benchmarks. One is Farmer-Locker criteria. Second one is HTMT criteria. Third one is cross-loadings. So we are going to understand whether we have three constructs like work stress, teamwork, helping behavior. Whether the particular constructs are independent, the kind of indicator, are the each construct, are they trying to measure what they intend to measure? Are they having any kind of overlap? So by using HTMT, by using Farmer-Locker criteria, by using cross-loadings, we try to see are they independent, are they overlapping between each other? So how to understand? HTMT value should be less than 0.85, or at least you can also go with up to 0.90. When it comes to cross-loadings, we are going to look at it whether each construct have higher values, its own construct as compared with the other construct. Just open this. Come to the discriminant validity. In discriminant validity, we have first one HTMT values. Now, just look at the HTMT value. The output shows that all the three pairs of measurement models like work stress to helping behavior, work stress to helping behavior, it is higher than the helping teamwork, right? Similarly, you can also the stress is compared with that teamwork. While comparing this particular construct with other construct, stress is having higher values. Similarly, when you're comparing with helping with other construct, this particular value is higher. So in this particular line, helping behavior HTMT values are greater than 0.85. That is one thing. Helping values. When you're looking at the outcome of the HTMT value, you need to see that whether this particular value is greater than 0.85 or at least 0.90. All the three constructs, we have values less than 0.85. It means we are able to achieve that all the three reflective models have achieved discriminant validity. Means they are not overlapping it. Coming to the next one, Farmer-Locker criteria. When you look at the Farmer-Locker criteria, we are looking at the square root of the ABE. Like for example, here, helping behavior 0.76, work stress we have 0.898, teamwork we have 0.881. All are larger than their correlation with other measures. This is larger than rest of the constructs. This is larger than rest of the constructs. This is larger than rest of the constructs. It means there is no concept of overlapping within the indicators. Okay. So all the three measures, there is no overlap. If you look at this particular cross, you should have all the measures, all the values should be higher in the respective columns. Okay. Last one we have cross loadings. When you look at the cross loadings, it indicates that whether are we able to achieve the discriminant validity or not. In our case, all are reflective constructs. So we are going to look at the entire cross loading values here. The output shows that all the indicators like helping behavior, if I'm looking at it, let me copy it here. If you look at here in this particular construct, if I'm looking at it, helping behavior wise, all the indicators have high correlation. They are strongly correlated within the construct. But if you look at, if you're comparing this helping behavior with other constructs, you can see that these particular values are less than the helping behavior construct. These particular values are less than the higher helping behavior construct. Now, when I look at second one, that is stress. Where is my mouse? Here. When I look at the stress, these particular indicators have high correlation when I compare with the rest of the constructs. Like this one, if you compare, if you look at here, they are in minus. This is in plus, right? These constructs are having good correlation. Second one, if I'm comparing teamwork with the rest of the two constructs, we can see that the cross-loading values are very high of this teamwork when I compare with the rest of the two constructs. It means helping behavior, work stress, teamwork, we are achieve the discriminant validity for the cross-loadings as well. So all the three parameters we are able to achieve, whether it is HDMT value, whether it is formal locker criteria, we are able to achieve it. Next one we have collinearity statistics. Just as you can see that on the next to the discriminant validity, we have collinearity statistics. We don't want to have multi-collinearity. Okay, so we just want to see whether there is higher correlation within the constructs. I'm looking at the outer loading values, outer model list. Here our value should be, if it is less than 3.0, that is well and good. Or at least it should be 5.0, less than 5.0. Now looking at the values here, I have 4.5, I have 6.05, I have 6.05, 4.9. Okay, this is just crossed. 4.44 is just near to 5. So there is one problem with the one of the indicator. It is stress 2. Stress 2. If VA value is larger than the benchmark, that is greater than 5.0, we should delete this particular indicator before going for further analysis. If you don't delete it, it is going to create some problem to your data and you cannot rely on your validity of your findings. So what we are going to do is just click on edit. Where is the stress here? Stress 3, right? We have values stress 3, stress 2, stress 2. Yeah, this one. I'm going to delete this particular indicator. So how to delete it? Select the particular indicator, right click, just click on delete. Now just click on delete. Once we delete it, just go back again, calculate, consistent PLS algorithm, start calculation. Blank, blank, blank. Now come to the collinearity test result, model fit. Sorry, not model fit. Collinearity test result, outer model. Look at here. All the VF values are less than 5.0. Means we are able to achieve collinearity analysis test. So there is no problem with that measurement model, like both construct validity and construct reliability. Just click on save. Now, just go back, just click on edit. Now, what we have to do is right now, we are going to conduct measurement model. Structural model. We have completed measurement model. Next step is structural model. How to measure the structural model, how to conduct the structural model analysis with the help of the SmartPLS. So we have 4 important factors. We are going to look at the R square value, path coefficient value, effect size, and predictive relevance. Now, if you want to look at the coefficient determination while doing analysis part, interpretation part, I'll come to that. We already discussed yesterday in previous class. Based on the path coefficient results, if you're getting a positive relationship, it means an independent variable increases, the dependent variable also increase. But if you're getting negative result, path coefficient result negative, an independent variable increase, the dependent variable decrease. So we have these are the some of the threshold values we have. Can check it out. Second one, t-test. Our test value should be greater than 1.96, and it should be significant. In case if it is reverse, it means there is no significant. If the results are insignificant. Okay. R square value, we are going to look at it. It depends on the R square value. We are going to say that how much independent variables have influence on the dependent variable, or how much this particular concept have influence, how much explanatory power we have it. We are going to explain with the help of the R square. Okay. Next, please go to the SmartPLS. Please come to the SmartPLS. We have done the edit. Click on, we have done it. Right now, before going to further, as we don't have any more work with the indicators, as a part of the structural model, we are only seeing the relationship between the constructs. We are not going to use any more, we don't have any more help of the indicators. We already measured it and they are reliable, they are valid. Now, the next step to see the relationship between the construct. So for that, what we are going to do, select the particular construct, right click, just click on hide indicators. Similarly, we are going to repeat the same. Just click on the particular construct, hide indicators, hide indicators. So we have done with the all the constructs. Now, once we hide the indicators, in order to obtain the path coefficients, just go to calculate, calculate. Now here, just consistent PLS-SEM bootstrapping, consistent PLS-SEM bootstrapping. Start calculation. We got the results. Now outer weight should be, measurement model should be blank. Then structure model, which are going to have path coefficient and p-values. And R square also we can able to see that. Okay. Now we are going to look at one by one. Teamwork. If I remove this part, R square right now, we are able to see how each construct is able to influence the other construct. How each, what kind of relationship we have. For example, here, whether it's a direct effect, significant effect, we have it. Here you can see that teamwork is having negative effect on the stress. And similarly, helping behavior is having negative effect on the stress. Means if there is more helping behavior, more teamwork, there will be less stress. I'm repeating again. We have two types of relationships, whether it is mediation or in general. In general, as a part of the structural model, if you look at it, if our path beta value, we have got the positive relationship, independent variable increases the dependent variable. Now here, negative relationship. In our test result, we got minus 0.534. Means if one teamwork increases, work stress is decreasing. So it is a positive sign. Though we got the negative. See, if we have good team, less stress, right? So here we got the minus. Second one, when we have good team, how much team is going to influence the helping behavior? 0.70. And it is a significant results. Similarly, helping behavior in influencing the stress, minus 0.33. If you have more helping behavior, more stress level. Okay. I can able to see teamwork is also influencing, helping behavior also influencing. We have significant results. But I just want to know both the variables together, how much variance, how much they're able to explain the variance in the dependent variable. For that, I'm going to use construct that is R square. Okay. I'm just using the R square. Sorry. sorry. Now just look at here. Both the variables together, they're able to contribute 0.64, almost 0.647, almost 65%. If I put in percentile, 65% both variables together, they are able to influence it. But what is the role of this one? What is the role of this one? Teamwork, after adding to the helping behavior, together they are able to contribute it. Together they are able to contribute here. Now, if I minus it, which is having more influence? Teamwork is having more influence. You can see that teamwork is contributing 50%. and adding with the helping behavior is contributing 65%, 64.7, 65%. So you are able to see the variance due to change in the dependent variable, I mean independent variable, how much variance we have. Second one, just go back, click on edit, calculate, PLS-SEM algorithm, start calculation. Measurement model will be blank. Structural model will be, we have F square. Construct will have R square. If you remember yesterday's session, we have discussed about what is the effect size, how to measure it. Yesterday's slides are more clear, I mean, in terms of the uh, reading point of view, because I believe you must have already watched it. Otherwise, I request you to watch it. I spend more time while explaining the structural model step by step. But today it is, as it is a revision, I'm going a little bit fast. Okay. Now, when it comes to the R square value, our test result is 0.64. 0.64. It means it is substantial. It is, as you can see, that is more than moderate. It is between moderate and substantial. It is good variance. We are able to explain it. Our explanatory power is, we are able to see the good variance, good explanatory power. Now, when it comes to path coefficient, there is a scope for -1 to +1. And we got it minus. And if fixed size, if it is 0.02 small, if it is 0.15 medium, if it is 0.35 large. Now, just look at here. It is 0.4. It is large effect size. 0.1. It is a medium effect size. 0.15. This is less than 0.15. 1.01. Okay. So almost close to the medium effect size when it comes to the helping behavior. Whereas when it comes to the next one, we have teamwork. It is having large effect size. It is greater than more than 0.35. Large effect size we have it. Look at the result here. 0.401. So teamwork is having more effect on stress as compared with the helping behavior. Both together, they are able to contribute, they are able to influence the stress level. The simple, if teamwork is very high, work stress will be less. Similarly, in addition to teamwork, if you are going to have good helping behavior, good coordination among your employees, both together they are adding to reduce the work stress. Okay, that is the important findings of our study. I hope it is clear. Next one, we are going with the mediation analysis. I already explained what is mediation at the beginning of the session. Now, how to conduct the mediation analysis. So just go back, click on save. I'll give you a structural model. Again, just click on edit. Click on edit. Now here, go to calculate. Go to calculate. What we are going to do is here, we are going to do it consistent PLS-SEM bootstrap. Start calculation. Now, come to the right side. We have path coefficient results. We have total indirect effect. We have total effect. We are going to look at the direct effect. That is path coefficient direct effect. We are going to look at the specific indirect effect. We are going to look at the total effect. Okay. Now, if you look at this slide here, as a part of our analysis part, I think it was in. So we are going to see direct relationship. Okay. And with the help of the mediator, what kind of indirect relation? With the help of the mediator, we We're also going to look at the indirect relationship. Okay. Plus total relationship. How total relationship will come? Total relationship, direct plus indirect is called total effect. Okay. Now, left side of the window, we have final results. Within the path coefficient, we have direct effect. Now, as a part of the direct effect, if you look at my results here, total effects, we have direct effect is minus 0.43. So we have seen it as a part of our test result. We have seen as a part of graphical output. Minus 5.34 minus 0.534 is the direct effect. Teamwork or stress. Look at here. This is stress, direct effect. Okay. Now, is it significant? Yes, it is having significant results. Now come to the indirect effect. That is teamwork to the helping behavior to the stress. How much is able to influence? Minus 0.3236. Okay. So this is again significant results. Now come to the total effect. Total effect. How we are getting the total effect here? See, this is what I just want to explain here. Direct effect plus indirect effect. Direct, don't mind about the some minor changes in the number. Okay, I was practicing by reducing certain numbers and all. It doesn't matter. It's almost close to that number. Okay, direct effect we got minus 0.527. Indirect effect minus 0.243. Direct effect plus indirect effect is called total effect. Total effect is minus 0.76. Okay, and there's a significant relationship we had. Now, look at the benchmark. I think this was teamwork wise. We looked at effect size. Teamwork to helping behavior, it is greater than 1. And teamwork to stress, it is large. Helping behavior to stress, it is a medium. The output indicates that there is a large direct effect of teamwork on work stress. That's what we have shown it. Right? Earlier, there is a direct effect is very high as compared with the indirect effect. And we are taking the help of the F-square while analyzing, while interpreting your reports, while interpreting your findings. While there is extreme large effect on teamwork on helping behavior, however, the effect size of helping behavior on work stresses, that is F-square test is 0.15. Okay, we have discussed. Now coming to the next part, predictive power. This one we have done it, like which is having more influence. We have two constructs, whether teamwork is having more influencing or helping behavior. Teamwork explains up to 51 alone. Teamwork alone, it is having 51%. But if we are combining with R-square, helping behavior, we're able to explain 64%. Okay, almost 65%. The conclusion is that teamwork is a powerful antidote to work stress and explaining nearly 65% of the variance that you are seeing right here. However, a significant portion of this benefit, that is minus 0.246, comes specifically from helping culture that teamwork facilitates. So management, what are the takeaways? If you want to come up with any kind of suggestion or outcome of your research, don't just group employees together, actively cultivate the specific helping behavior that mediates the stress reduction process. So that is the main takeaway from this particular findings of the study. Now, when it comes to the reporting, we assess the mediation of helping behavior and the relationship between teamwork and stress. The bootstrapping analysis revealed a significant indirect effect, that is 95% confident interval. Furthermore, the direct effect remained significant and positive. Thus, we conclude that complementary mediation is present. It is a partial mediation. Okay. Because the direct effect also we have it, we also have indirect effect. Both together they are contributing. It's called partial mediation analysis. So we are going to discuss what is PLS predict, what is CVPAT, and how to assess it. Okay. Now the question comes here. Once we complete your measurement model, structural model, and what are the mediation, moderation, multi-group analysis that we have done it. At the end of the day, as a researcher, you want to see that how this particular research can be implemented, right? So as a researcher, you want to generalize your findings, or you want to apply this particular findings with the rest of the society or rest of the community, or in different sector, different industry. So what we have done so far, we have collected data and we have assessed whether this particular model is how it is able to predict it, right? Now, I just want to apply this particular data out of the sample. We have two types of sample. One is in sample, that is the data that I collected it. And we are going to compare the data with the out sample, which is not with other data sets. Other data set does not coming from anywhere from outside. We are going to take this particular data into 10 folds or 5 folds. And one fifth of your data, 1/10 of your data, we are going to compare, resample, and we'll see how this particular data is having good prediction. Not only explaining whether this particular can able to come up some good prediction, accurately can able to observe it or not. So for that, we are going to use PLS predict. In that particular PLS predict, we have a couple of parameters like Q-square value. If your value is greater than 0, your model is having predictive relevance. Okay, based on if it is greater than 0, the model that you have it, the model that you explored, that is having good prediction level. Now, we also have a couple of parameters, whether your data distributed normally or not. If your data distributed normally, we are going to take the values of RMSE, that is nothing but root mean squared error. Basically, we use it while comparing our data with the observed data. Okay. In case your data is not distributed normally, we are going to take the values of skewed, that is mean absolute errors. Okay. However, in both the cases, while comparing our observed data with the predicted data, our value should be lower. If we are getting low value, means our accuracy is very high, our prediction level is very high. Okay. So first one, what we'll see one by one. We are going to see first one Q square. Then we'll see whether our data distributed normality or not. If not, we'll go for MAE. If it is distributed normally, we'll go for RMSE. Okay. Let's see. What is the importance of conducting a prediction model? PLS-SEM, we deal with the latent variables, like we have construct like a teamwork, stress, helping behavior. These are all the latent variables which are not observed directly, but we have measured them with the help of the indicators, right? Latent variable concept that I have not directly measured, but inferred from observed data. So it is not enough for a model to simply fit the data. It has already seen. To be specific, to be scientifically robust, we must evaluate predictive accuracy. So that is the purpose why we are looking at PLS predict. As a researcher, if you are going to publish your paper, and please ensure that at least you are going to have findings on PLS predict. Either you can use PLS predict or CVPAT. It is not compulsory that you have to use both. If it is a PhD thesis, you can think of using both together. Otherwise, one of them is sufficient. Okay. So we have two types of data. Training data, nothing but the data that you collected, the data that you explored with the help of the PLS-SEM. Testing set, which we haven't seen it, but we are going to evaluate our training data with the testing data. How it is? Where is that slide? I think missed it. I just missed that slide. No problem. I'll show you that. So what is testing data? I'll show you. Just click on edit. Just click on the edit. Now, as we are going to conduct the PLS predict, go to calculate. I hope you are there with me. Go to calculate. There is an option called PLS predict. Now here, as you can see that number of folds, we are going to consider our entire data. We are going to divide it into number of folds, and we are going to repeat number of tests 10 times. Like as you can see here, PLS predict algorithm has been developed by so and so. The method uses training, and training means the data that are collected, that is observed, and holdouts, that is test data to generate. It is going to test. It is going to generate test data and evaluate predictions from PLS path model as estimates. The results also include the outcomes of cross-validated predictive. So we are also going to have CVPAT results as well. So how many times you are going to do it? 10 times, 10 repetitions. Okay. Just click on start calculation. After doing this particular part, please come to the PLS predict MV summary. And we are also going to see prediction descriptors. PLS-SEM LV predict summary. Okay. This is the final output. But this is final output. But before going to this particular final output, I just want to show you a few important points. Our Q square value should be greater than 0. If you look at for all the indicators, our Q square predict value is greater than 0. That is 0.28. We are 0.28. Means we have predictive relevance, point number 1. Point number 2, we have PLS-SEM RMSE. We have linear method RMSE. Which one we have to opt for? Now, the point that I mentioned, that whether our data distributed normally, then we'll go for PLS-SEM RMSE. In case our data is not distributed normally, I mean in terms of this particular, as we're comparing these two, not distributed normally, we'll go for LM RMSE. How to understand, where to understand for that? We need to see that we have option called histogram. Just come here. Look at this particular data set. I hope you are able to see this. You are able to see this here. Our data, with the help of the histogram, we are able to see indicator wise. For every indicator, it is going to present. For every indicator wise, it is going to present whether our data distributed normally or not. Okay. Second part, once we get the clarity whether you have a normality distribution or not, you're going to decide whether you're going to take PLS-SEM values, RMSE value, or LM RMSE value. Right. Just come to this slide. PLS-SEM complex structural model, it captures indirect paths and mediation. Whereas when it comes to linear model, it is based on simple linear regression. It only takes the direct relationship. Okay. Next part, we have indicators. PLS-SEM indicators we have. LM RMSE indicators we have. Now the question is that how many indicators we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 10 indicators, if all the indicators, for example, PLS-SEM error is lower on all indicators. If I'm comparing this two, if I compare this two, PLS-SEM RMSE with LM RSE, if I compare this one, if my PLS-SEM indicators are less as compared with the LM RMSE, means we have our error is very low. If all the indicators have less than LM RSE, it means we have more prediction errors. I mean, less prediction errors we have. PLS-SEM error is lower if you have all the indicators are less than LM RSE. But in case if half of the indicators are RMSE, half of the indicators are LM RSE, in that case, we have medium level prediction errors we have. PLS-SEM error is lower on the minority, less than of indicators. If you have PLS-SEM values are higher than RMSE values, then it means we have more PLS-SEM errors we have. Okay, so that is the indication. This is what yesterday I have missed it. I couldn't explain this one. I missed it. Okay. Now, lastly, we always look for our data distributed normality. And your data distributed normally will take RMSE values. And based on the number of indicators, after comparing between PLS-SEM, LM methods, we'll see whether we are able to have prediction level is high or low. Since 6 out of 9 indicators showed lower errors of PLS-SEM, the model effectively predicts the causal relationship in the particular context wise. This is okay. Next one. If you want to have a brief summary of what you have done, we are able to test our training data with the test data 10 folds as a part of the PLS software. And we are able to check it, Q-square value should be greater than 0. And we are able to check whether data distributed normality or not. And we are comparing our MV summary PLS-SEM errors with the LM errors. Okay. And we are going to come up with conclusion based on the indicators. If all the indicators are less than the LM, then we have low prediction errors. If half of the indicators have both sides, then we have medium level prediction errors. Okay. But if we have more number of indicators have higher values as compared with the LM, in that case, our model is have more errors, more prediction errors. Okay. So what is the takeaway? Q square tells us if the model predicts or not, how much relevant it is. Whereas RMSE MA tells us how accurately it predicts. Okay. So our score should be lower. Whether it is RMSE, whether MAE, our value should be lower, so that we can say that our number of prediction errors are low. Next one we have this last one, CVPAT. How to conduct the CVPAT? And what is the CVPAT here? Cross-validated predictive ability test is a rigorous method to evaluate the predictive capabilities of your model. It is as compared with the PLS predict, CVPAT model is considered a more rigorous method to evaluate the predictive capabilities of your model. It serves as an alternative or complement to PLS predict. Means it is not compulsory that you have to use both PLS predict as well as CVPAT. It can be an alternative method for you. So you can decide which one you want to use as a part of your research paper, as a part of it. Now, if you want to understand whether CVPAT, the kind of model, prediction model, how much rigorous it is, here we have 3 important concepts, like 3 important benchmarks. Like we are going to compare our PLS-SEM model with this indicator average linear model. Indicator average is nothing but it is a average of the model. Like your model must beat this. If you cannot predict better than the average, the model adds no value. So we are going to compare PLS-SEM model with the indicator average. If you're getting the average results, it's not having any value. Whereas when it comes to the linear model, your model should beat or tie. A tie confirms the robust. If it is greater than that, it is considered the robust. So let's see which one is going to be higher. As we did yesterday, we should always look for our value should be negative. Our value should be negative. If it is a positive, you can see that our PLS errors are more than benchmark. If it is a negative, our PLS errors are less than the benchmark. Okay. So we are going to see who is going to win, whether PLS is going to win or other 2 indicators are going to win here. So we are going to conduct PLS-SEM with the help of the CVPAT, and we are going to look at compare PLS-SEM score with the indicator average score, and we are going to compare PLS-SEM with the linear model score. Okay, just please come here. Just click on edit. I think it was done, right? Yes, it was done. Sorry. Open the report. PLS predict. CVPAT. In CVPAT, I'm just looking at the PLS-SEM versus indicator average. Now, PLS-SEM minus indicator average, if you calculate, and we are getting average losses minus 1.4. We have 2 construct, helping behavior and the stress. And you can see that if you calculate minus 3.4 minus 4.8, we are getting minus 1.4. Similarly, 3.0 minus 5.2, if you calculate, minus 2, and it is a significant results. So we are looking for the negative result in terms of the average loss, and our value should be significant. So we are able to achieve with reference to PLS-SEM with the indicator average. Whereas when it comes to the second one, here you can see that PLS-SEM 3.4, LM 3.6, stress 3.0, this is 2.9. 2.9. So you can just, we need to see that there is some tie almost. Overall, if you look at here, 3.3 to 3.40. Now, out of this construct, one indicator is having tie-up. CVPAT summary. Overall, you can see that we have got the significant results. And overall, you can see that 0.4. If you look at the overall summary, twice, PLS values are less than AI. This one, okay. Okay, so based on this two, we are going to come up with the interpretation part. Just let me show you what is the interpretation. This is what we have discussed. As compared with the PLS loss, AI indicator average score is very high. So our conclusion is that the PLS model has a significantly higher predictive power than simple averages. Indicator average is only talking about average. Okay. So high T values confirm that strength of this particular relationship. Okay. We have good strength and good prediction we have as compared with the indicator average. And we also have PLS-SEM comparison with the linear model. As I mentioned at the beginning, this particular data, there are some minor changes. As I was practicing by deleting one or two variables and all, a couple of numbers. Here you can see that this is higher. So you can see that there is one tie, right? First one is significant. We are able to win it. Third one is a tie. It is okay to tie to the linear. The stress shows p-value of 0.81. This means that difference is negligible. 3.01 minus 2.90. Difference is very negligible. Your complex model performs just as well as the robust linear model and validating its quality. When it comes to the final concluding part, while reporting your research report, CVPAT demonstrates that PLS-SEM model yielded lower prediction errors than AI benchmark. Okay, so you can give a particular variable, whichever the context that you are doing as a part of your report. Average loss is equal to value and p-value less than 0.05, indicating higher predictive power. Compared to the linear model, the PLS-SEM model showed like we have got the type, right? And values are not significant. Predictive performer for the variable, and we are going to come up with the analysis part.